We are live. Hi. Quite a lot to do this week. Let me get Restream open. And we'll go through some of the experiments that have run overnight to start with. And we'll see where we go from there. Looks like they all ran correctly this time. Start with Adam. About 44-second solve. Which is better than before for Adam. That's solid. That is solid. Any interesting bits with that? I see we have higher value function coefficients. We've got some higher entropy a little bit, higher BPT. So yeah, it's used all the new horizons, or the new maximums I set on some of these hyperparameters. It's an important thing is if you're doing sweeps and you see it butting up the edge of the range of what you've allowed, gotta increase the range. Epsilon doesn't seem to do much. Cool. So now exact same thing, but with muon. "31 seconds, and down there's a 24. It's pretty well a 30-second solve. Definitely better. That's pretty nice. I think we will just look at 25.0621. That's a clean RL curve. That is solid. You kind of wonder if at the end, it doesn't get, it's a little shallower. You almost wonder if I want to start sweeping cosine annealing params. That would be a bit much, but you're pretty well solved in 30 seconds. This is a 78 million step run. No, this is the final learning rate. Don't worry about that. 4096 total M's, which is what you would expect for a very efficient run. It's perfect. Let's look at some of these hypers. So I think the default's 0.9 here and 0.999, so actually very close to the defaults. Atom epsilon has gone all the way down. That's interesting. Annealing the learning rate, yes. It increased the maximum batch size. That means I have to up this number yet again. 64 horizon. Let's actually get the let's get the config window open so I can like tweak some of these live. This is a really nice result. so for sweep ranges here, I set a max of 64, and go up to 128. I don't know if that will create invalid. Shouldn't create invalid settings, so I think that's good. Batch size actually has to go up as well. It's at the upper end of this, so this is 1. Yeah. Do we increase the mean? I think we do increase the mean. Atom epsilon is it? Add a couple zeros in there. I think you can actually just do 1e minus 12 or whatever. We'll leave it for now. What else has been swept here? Okay, interestingly, we had a very high entropy coefficient before, but now it is not anywhere near that. So I guess it just found a different setting. Lambda, gamma, within normal ranges, I would say. Yeah, 9999. Okay, so within normal ranges. Mini batch size of 8192. I think that's my default. And the value function coefficient is 2.17. But max grad norm. Did I see that in there? 0.38. So it's interesting that it doesn't always find. Oh wait, here. There's also, I missed, the learning rate is very high. So it's interesting it doesn't always find like the exact same parameters. That kind of means that either there are like multiple good regions, or that maybe some of these are just stable across very wide ranges. Though I think it's likely the former. Okay, let's get these into breakout. Make sure this replicates. I'll post this as well, because this is a cool result. You see one of my contributors has gotten Path of Exiled. Chat's not up, FYI. My bad. Morning. Muon seems faster with breakout at least. Yep. It's I think Muon is going to be just a good addition overall. How was your run yesterday? Run was pretty good. Did about 6 miles with my dad. We had to stop for something after 4 miles, but then we went fast for the last 2, so it was good. Went to the gym after that. Haven't been to that gym in a while. I've never been into their big bodybuilding section, and it's actually like a ridiculously well-equipped gym. It's like all of the best machines on the market, and it with a $30 membership. It's crazy. I was there doing a little bit of reconnaissance, trying to figure out what I want to buy. Found a few awesome things. No, I am buying equipment, because this gym is here in Florida. Equipment's for Maryland. Yeah, it's like 30 bucks a month. And like it's four separate gyms in one gym with like, I don't know, at least 100 different machines. They have like probably every Atlantis, Prime, Arsenal, Cybex. They've got like every good machine that you would want to see. Are you moving or I seasonally? It's gonna be seasonal. Florida's my residence still, and I'm here in the winter. Need a summer home in Colorado. Florida in the summer is just not a fun time at all, generally. Just really isn't. So I spend, the plan is winter in, like a couple months in the winter, 2, 3 months in the winter here. A few months in the summer in California, depending on what I'm doing there. And then fall and spring in Maryland. It's going to be the most likely outcome. And the Maryland one is going to be the best outfitted for all my work because we have the most space by a mile. Yep, that it is. Mhm. There's a reason I'm not staying in California year round. Isn't that funny? That's how badly they gimp themselves with with what they're doing currently. If they had no state tax, it'd be pretty easy. Like everyone would just be there. Moving. Oh, I'm with my family here and kind of in Maryland. Not quite. They paid double for gas. Yeah, I don't. It's kind of sad. I don't know what they're doing. The economics are totally screwed. At least I will say Palo Alto is still like it's nice there. SF is a hellhole. Like with some of the stuff that's happened in SF lately, I don't think I'm even taking business meetings in SF anymore. Like I think I'm just not going to SF. It's like nah, screw that. Y'all can come down to Mountain View or Palo Alto where we're civilized. SF is run by the VC car. It's certainly run by a cartel. I don't know about the VC one. You got the first part right. But yeah, when founders are getting beat over the head with metal pipes, no thank you. I have worked too hard to live somewhere or to even be somewhere where founders get beat over the head with metal pipes. No thank you. I will be literally anywhere else. That sounds like a smarter thing to do. Especially in AI. I didn't realize value coefficient could go above one. It's a coefficient. It's not like a logit space thing, right? It's just a multiple of a loss. And it couldn't before in sweeps. I increased the range because I noticed it was always up against 1. That's part of one of the things, I don't know if you were here for when I started streaming and said that, but when you see that your sweeps are pushing up against one end of the range, you gotta increase the range. You see? Now, obviously, you don't go, oh, well, what if we just make gamma over 1? Yeah, that doesn't make any sense. I haven't swept any of the clip coefficients in a while either. We might go back to doing that again. But yeah, this is kind of cool. Batch size 500K breakout params. We can get rid of these now. It's pretty damn cool, right? Why is this one 55 seconds? Oh, it's not. Hold on. Because I just ran it for longer to make sure it would be stable. Let's run it a couple times to see if it's, needs any tweak. But yeah, this is what I'm saying, right? Like, once you get everything lined up correctly. Yeah, this is breakout. I mean, what we're doing here, we're kind of using the breakout speed run as just a benchmark for general algorithm stuff. It's not like I'm hacking on the reward function or anything. I haven't touched it. And we've gone down from 5 minutes to damn near 30 seconds. And then the original breakout, like that most of the labs use, takes several hours. What were the changes that made the curves that smooth? So this is just running faster and with a substantially larger batch size. So that's going to prevent some of the jaggedness. But then like the big dips and stuff that you were getting before, better optimizer, better learning rate scheduler, actually just improving the speed of some of the stuff allows it to take advantage of larger batch sizes, which then translates to smoother curves. Like, yeah, it's kind of magic. When you get everything right, it just works. That's another run right there. And actually, you see how there's this little like dip, right? Like this? Like these dips aren't even from it being weird. These dips are from the cosine annealing learning rate scheduling. Yeah, no, this is literally compared to like original CleanRL speeds. And you got to give them a little bit of credit because I think, they were doing from pixels. So, okay, the net has to be a bit bigger. But still, Like, the original there, this is over 1,500 times faster. And I think even over an optimized implementation, like the optimized CleanRL or whatever, which doesn't even have LSTM support, I think is like 300 times slower than this. Like I said, this is what we're doing with RL. Okay, now imagine this everywhere in RL, right? Imagine this on neural MMO3, on whatever industry problem you do, everywhere. And let's imagine that we also figure out the like roughly out of the box hyperparameters that are going to get close to this before you even tune. That's RL back right there, man. That's RL back. Look at that. A little bit of variance. A little bit of variance. Not much though. I think we can make this even a little faster. Hang on. Yeah, because this agent steps, hold on. This is 50 million steps. Maybe we reduce it to 60. See how that changes the curves. I always go a little bit above whatever we got in the train run in steps. Because, like, even if it's this consistent, right? I'm always going to assume that we got this run in the training, right? We got a little bit lucky. So I have to add a few steps in case we get this run, right? When we actually go to do it. Does torch compile help? Let me, I will check. Yeah, so that worked perfectly. Not noticeably. No noticeable difference. Though possibly, there's like the coup de grace stuff that we could look into that could make a decent difference. But there's no noticeable difference right here with that. Linear, yes, linear is the default, Captain, that we replaced with cosine. And cosine's better. This is insane. I remember training a baseline months ago. Struggled to get 5 minutes, now 30 to 40. Yeah. Isn't this cool? And look how consistent this is as well. Like, this is not just faster, it's also like fundamentally, this feels like stable. And if you look at the hyperparams, and they actually make sense. I mean, yeah, Spencer helped us get it to 5 minutes as well. It was way longer before that. That's no, what's no, let's just see if this does anything. I don't have remotely good params. Let's just see if we be a little cocky. Several hours with high variance down to 30 seconds with, yeah, exactly. Now, to be fair, a big chunk of the initial perf gain there, like, we had to cut down, we had to go from the original Atari M to our version that's way faster. Because the original Atari, we could only get to run about 30,000 steps per second. I mean, but still, if we have to run 60 million steps, I think that's still down to like 40 minutes or whatever, with the same algorithm. And then the thing is, it would tune separately. Like, the tuning would apply differently. So 40 minutes would be like a high end. It's probably way shorter than that. And the original M's are in C. It's just that people decided to train on pixels for no damn reason. Okay, so this is like the original Pong params, which are completely wrong at the moment, right? Like, the Pong params are completely wrong because of all the changes that we made. And with the new optimizer, just like throwing in muon and the like network changes and cosine annealing with whatever the hell hyperparams are there, it still works. And not only does it still work, it still works with a consistent training curve. These little jaggies here are just like the batch size being slightly smaller. The point is you don't get any like massive dips and then recoveries. So yeah, that's just Pong solved. I was gonna try to get it on Neural MMO and stuff right now. But Connect 4 is also good. Oh. Look at that. I think we're going to tune everything, Captain. So I think what we'll do now is let's see if I can go look and look at the defaults, if we can improve some of the defaults, and then see if with the defaults changed, if we can get better perf. Like, let's see if I can get Pong to do way better just by changing the defaults, and then see if those defaults just learn anything at all on a harder end. We'll do a lot of this type of stuff today. And then aside from that, the only two things I think I really need to do today, I have one client env that needs to be integrated, and we need to throw some puffer stuff on. And then I have another client env that needs me to look at what the hell's wrong with the god-awful Python. And other than that, I think we're good. So I have lots of time now this week. We finished one of the previous contracts, which is great. So I have a little more time. Okay, let's look at these in comparison to the defaults next. Very high learning rate. Float 16 is slower for small networks. I tested it. It's faster. I got like a 15% perf boost on neural MMO with a like 1 mil per mnet, and it was substantially slower on the smaller nets that we use normally. Close. $700K might be a little faster. I wouldn't do that though until you've timed it, man. Also, I have a way to eliminate copy time. I don't think it works until Python 3.14 though. Let me show you this real quick because I thought this was kind of cool. I had a really productive Saturday. It was hard work. I was like grinding this stuff out on Saturday. But here. I made a threading-based backend, basically. So this is multi-threading backend. And this is kind of cool because what you can do here is you can pass stuff in as torch tensors, right? So you pass in torch tensors, and then on the individual process, right, or on the thread, you can queue up the transfer directly to the torch tensor. So you do the async memory, you do the memory transfers async, which I think, depending on how CUDA works under the hood, should actually cut that time out completely. Now, the problem with this is I tried to do this with the multiprocessing version with PyTorch like shared memory tensors, and it's technically possible, but it's really like a total pain in the ass because of the way that you can't use multiprocessing fork with this, and we rely heavily on fork in order for this to work. So really, it's just going to be a lot easier once we get the true threading stuff in Python 3.14. No IPC. I mean, no, there's still async shenanigans. You can't just be totally stupid about stuff because threads versus multiprocessing. Like, the implementation is actually going to look very, very similar. But yeah. Have you set a 2.5 release goal? Not really. It's kind of just whenever I feel like we have enough stuff to merit a big release. I don't like doing short release cycles because, like, there's always going to be a certain number of bugs that you have to fix with every release, and you have to do a lot of work to, like, get everything back stable and stuff. So I kind of like having the longer release cycles where I can really, like, come up with something really cool that'll get people excited. And then, if people want access to stuff early, they can either very closely monitor the dev branch, or if they're companies, they can get a support contract. And then you basically get access to news on all the developments up to 6 months early. I think that's a pretty good model. It saves me work, and, companies get value out of it too. I like this. uh, don't don't do LLMs, folks. Don't do LLMs. Just say no to LLMs. Just say no. Just say no to LLMs. I like that. Okay, first thing is, what if I just do this? The thing is, they're kind of right. Like, there's so much stupid hype in LLMs right now. Yeah, let me show you the latest thing that I tried to use LLMs for. It's like I literally regret opening them every single time I do. Go find me a piece of ab equipment from one of these brands. Okay, try this. Doesn't exist. Just made up a piece of equipment. Oh, look, see, I searched all the web pages. I'm going to go actually return search results. Nope. Made it up. And then I tried ChatGPT, and guess what? It didn't make it up, but it gave me a completely stupid suggestion that made no sense. Yeah, exactly. And then you have like the absolute morons who are like, oh, you need to learn how to become the prompt wizard. See, I'm so smart. I know how to type things into an LLM, even though I can't write any code. Uh-oh. That doesn't look great. Huh? Wait, what? Project is an art form. Well, there was something happening here. Aren't. I'd rather spend my time learning how to do the thing rather than learning how to coax the LLM into figuring out a thing. Making numerical models. I don't know. I've tried it in like various different capacities in my research, and it's always been a wasted time. Like, it's kind of a decent rubber duck that like can kind of spit out some sort of math-looking things. You can describe formulas and it'll write them up in LaTeX like really, really nice and quick. It's kind of nice for that, but like it can't really. It just is just not that smart. Report intervals 128. I don't know, maybe you've got a good use case, but I think I'm doing even simpler math than you, and it's not that helpful. Something is definitely screwy here that we're not getting back report results. Oh, there it is. What did I have before? Just like really tiny mini batch size? This was what I had before. But that's gonna make it like slower wall clock. I mean, it runs. It's probably faster too, right? Like if I just do like 150 mil, this is probably still faster than the original. Let's not do checkpoint interval 25. GPU drive question: does splitting each observation modality to be processed independently in their own layer make that much of a difference versus one layer for all obs? Does splitting each observation I think we've talked something about architectures, right, Spencer? Because the question doesn't make sense. And this is why I don't want to delete this. Let's find another one. Where's this? Paint online, cool. So like you have like self So how does it make sense to process these together? Because here you have, this is a vector, right? And like this needs to go through a linear layer. Okay, and then this needs to go, this other thing, this needs to go like through some linear layers or whatever, and then needs to get like maxed, right? As an embedding. And then this probably needs to go through like, you know, a CNN of some sort. And then go through a linear layer. So you can't like concatenate all these together and put them through the same layer, right? So what's the question here? It's not whether it makes much of a difference. It's like, how do you even do it the other way? You're not going to flatten all the data. Well, yeah, but that's kind of like saying, okay, an image is a list of floats. Why don't we use flat, like, why don't we use linear layers for, like, instead of confnets, right? Do you know why? I think we've had this conversation before. It's a very important and fundamental one to understand, if not. Like, why do we use, if you have an image, right? Why do we use a convnet instead of a linear layer? It's separation, and it's the same intuition for everything. It just applies a little differently, right? So the idea here is that if you were to learn separately a weight for each of these inputs, like a linear layer does, then you have to learn like all sorts of different, like you have to learn a representation for here, you have to learn a representation here, you have to learn a representation here. Now what a conv says is, hey, you probably want to learn the same representation over here, right, as over here. So no matter where you apply this filter to the image, it's going to do the same thing. And you get this automatically just from the structure of the network, right? That's why you do it. It's because you assume that in an image, it says, hey, you know, this part of the image over here is generally going to behave the same as over here, as over here, as over here, right? Now you can construct a setting in which this doesn't hold true, right? You can construct counterexamples, but generally this is a pretty darn good assumption, okay? Now the same thing with the cars, right? If you have like 1, 2, 3, 4 different cars you can see, or entities, this is an entity encoder, right? What happens if I switch the positions of these two, right? What happens if I see the cars in a different order? I have to learn a representation now with a flat linear layer that is robust to that, and that's really hard to do, right? You have to kind of relearn the same representation many times. But if you use an entity style encoder where you just do this in max, then you can flip these around however you want, right? And it's invariant. You provably will get the same output. So that's why you do this. And now the thing with, like the same thing with attention, right? What is attention? Attention is just a fancy way of doing this exact operation. What I just described here, this is an attentional encoder, right? A transformer is just a very fancy way of doing this operation, but it still has this key property of the order doesn't matter. Now, why you do this for language is a little bit more complicated because you also have positional encodings, but you know, for this type of case, that holds true precisely. So very, very important to understand that. And also, we solved breakout while I was talking, which is with like a completely random asset of hyperparameters, and in less time than the original. We didn't get like So this is not even a weird graph. It's just we didn't get enough like data points in it. But yeah, so there we go. There's breakout in a minute. I think the original was breakout in 30 seconds, so we'll have to sweep this separately. But it looks like just out of the box, those hypers are kind of fine. MOBA use one for the ordering issue. MOBA doesn't have any sort of entity encoder. MOBA just has a conv encoder. It just has a conv encoder, I'm pretty sure. So I just packed the entities. Like I picked whatever properties I wanted you to be able to see of the other agents, and I packed them into the conv. Same thing with neural MMO. It's also a perfectly fine representation. I did that so I wouldn't have to deal with entity encoders. Okay, so this is pretty sweet. What else can we just insta-solve with this? Enduro? This doesn't even have optimized hypers. Be easier to see. I'm gonna go through them. I'm working my way up. So the original config here is pretty fast. But days completed is stuck at 0. I think this one just takes a little bit though to because like the episodes are really long, so you just have to like, yeah, it's tough. Past Cars is also a decent one, I think. Yeah, there's days completed going up. I think I gotta ask Bet why Cars Past can't be the score. Because I think Past Cars should pretty well just tell you what is the best. Okay, so here's your days completed. Okay. And now what happens if I just get rid of all this? So say at 1.1. I mean, this is like the same set of hypers from everything. Hey, how's it going, man? This is the same set of hypers for 3 environments so far or whatever, and it's like these are fine for everything. It's pretty darn cool. And we haven't even fixed the GAE nonsense yet. It's not bad. We'll have to sweep it, but I think this is fine for now. It's like, it'll take off, you give it a little longer. I mean, that works. What do we do next? Which end? Let me see. Rware? Neural MMO is going to just take longer. Is Spencer still here? Let's see. Pushing tower climb. How long's tower climb take to train? Whoa. We had to do that. We had to take these steps way down. 50 mil. Do you think I should be able to pull dev branch? I mean, if you are gonna overwrite your local, I would make sure you have that saved because dev is never like guaranteed stable. But yeah, we have a whole bunch of cool stuff in dev for sure. Adjust the number of PLG maps. All right. What do you think it should be, Spencer? I tried. Take a few minutes to generate them all. It looked like it was only doing 100. Oh, is it more? Isn't the generation code in C? Why does it take so long? You had to do some fancy checking. Purposes of online demos. Okay, it's verifying. Well, it has like 50 in there. Oh, adjust it up, I see. Here, let me fix one thing first. Yeah, I broke multi-layer LSTM. Doesn't matter. And does it start learning relatively quickly or not really? Cool. I pretty much just want to test like our new params versus whatever you swept. I forgot we had tower climb now. That's a nice new environment for testing things with. It's whatever it's just the optimizer. Muon has some stuff set by default. I think we're gonna like get rid of this in whatever version we release because it's really obnoxious. Right, I think it should only bother doing this stuff if you set like the rest of the optimization flags to compile. Okay, so this is your hypers with the new changes. You're at 1,000,000 steps per second already, so I wouldn't be surprised that we underperform your hypers. Oh. Well, I didn't even change any of that yet, Spencer. This is just from, like, our general purpose improvements. It'll go faster than this, don't worry. Was it rose cleared? The one thing I would ask you to do is, I want all of the environments to have a variable score, which is the thing that you optimize over if possible. I can hack around it in the meantime. I can hack around it in the meantime, but it is way better if all the ends have a score variable. I think that we're gonna do that for everything. We'll go back. Yeah, but I think like even if you just duplicate the same variable name, like I think we need to have one named score so that when you run like a sweep or something and you set up your panels, right, for whatever environment you're looking at, you can just look at score. So here's levels completed. Presumably this is 93% of levels. Mm-hmm. And now let's see what happens if I do this. I'm gonna do 2048 M's as well because of reasons. Let me see, what did you have on here? Oh no, you actually did have 2 M's, 2 workers. So we can do 4096 for you. That should have been faster. Unless you had a really big mini batch before. Yeah, you had a big mini batch size before, I think. Yeah, so the 1 mil or whatever came from our optimizations, so that is still 900K. I mean, we can probably, maybe your params are better in this case, we'll see. Interesting. So it levels out a little bit at 80 now. What did we screw with here? Probably Gamma Lambda are the culprits. Something like that. Oh, entropy is probably, or entropy it could be. No, your entropy is pretty close. Easy. Well, yeah, but I'm just doing quick little experiments anyways right now. We can run full sweeps for you. Right. So we'll leave your hypers alone. But the key thing that I was looking for, which we confirmed, is that the defaults just do something, right? The defaults get you 80% solve rate before you even sweep. And also we made yours, your swept params go to a mil. I want to try MOBA. Yeah, it's Puffer fast. Oops. MOBA's a lot harder. Let's see. Let's see if this does anything. MOBA's like a lot harder. Also, I think it's going to break some of our slicing optimizations. Well, I didn't really do very many experiments on MOBA or on Neural MMO, right? I kind of just built them when I was building cool M's and like ran a few things. Like the bots in MOBA at the moment, they just know how to run down mid and use their abilities. How good are the scripted opponents? They run down mid and spam their abilities, I'm pretty sure. Why is backwards pass so expensive? Because it's set to 3 update epochs. This one has a ton of metrics on it. It is training, though. See, now it wins all the games. Okay? What happens if I do this? This one I remember being a total pain to tune as well. So I will be very impressed if this works. Why is sweep metric radiant tower saliva and not win rate? Because win rate's going to be 0 a lot of the time. So how many towers you have left just ends up being a pretty darn good one. Because also it's like, if you win with 0 towers taken, like having lost 0's tower, that's also probably a better policy. You can't use dire towers taken or whatever, because you can take all the enemy towers and still lose. So it's a little tricky. Oh. Haha. Invite slice. Another optimization. I will have to come back to this particular one. Why does it not work in the meantime, though? I think there's an optimization missing here. Minor bug fix. Interesting that the the env is the slow thing now. That's unfortunate. But I can probably fix that just with like get out of here, bot. I build the bots here. Run palm sweep. Oh, Radiant Victory won. Ha. And it's faster. I was just doing this on the side. Look at that. That's kind of crazy. So I just deleted all the hyperparams. I made it faster. And yeah, there's your victory. Instantly. So I think it's safe to say that we've got something here. I think it's safe to say we've got something here. I'll be back in a few. Gotta do a couple quick things. I can get more tea as well. And then I think we're gonna see if we can get Neural MMO working, because holy hell is this good. I mean, I don't think I can even like express how crazy it is to just delete the nicely tuned hyperparameters, throw on a janky set of defaults from Breakout, and then outperform by a mile like the best thing I previously got from tuning on what was already the best PPO implementation out there, and make it faster. That's insane. So I'll be back soon, and we will. I think we're gonna make a big dent on RL overall today. Be back. Okay, cool. Whoops. Let me do a thing real quick. 1 second. Bye. Let me send a couple quick messages and we're going to run some awesome experiments. Send a couple quick messages and then we're going to run neural MMO. Okay. This is insane right here. I don't know if I can describe how insane this is. So, yeah, that's crazy. Neural MMO 3 is up next. We also have Pong sweeps running. So, I don't know if you can read this access. Let me add some, let me add this so you can see. The original train access for Neural MMO 3 is 107 billion time steps. I chose this number because it's equal to, I believe, 2,025 years worth of gameplay. Where's the report interval? $120, it's hard-coded. Oh wait, hang on. This one is hard-coded. This one is not. Let's see about this. There we go. So now we have stable reporting. And I believe we want to look at min conv prof. Maybe this one's a little ambitious because this is one where it just took a lot of training. See what params we have. Very low learning rate. What about episode length? Or return? Okay, episode length at least is increasing. So this is potentially, the signal that at least the agents are surviving for longer. And then eventually that translates into them accomplishing stuff in the environment. We'll let this run for 100 mil. I mean, you can see that the original here was like almost a 3-day run. Original was like almost a 3-day run. Oh, and this is now with the new optimizer as well. Just with the old parameters. Okay, so 100 million agent steps gives you about 100-ish survival time, is what we see here, right? And I think you disabled annealing, you disabled a ton of other stuff that tends to be important. So why don't we do, this is just going to be 100 mil. It's a tiny number of steps by comparison for neural MMO. And and we just get rid of all of this. How many agents? 5 times this. Yeah, so this is going to be 8192 total agents. Just get rid of this. So we will also put compile on because it does make it a little bit faster. For comparison, right, this is what we had before. It was 1 update epoch, which was good. It was good batch sizes. I think the mini batch was kind of crazy. Okay, something's wrong with this because it shouldn't be this slow. Yeah, so it was compile screwing it up. Interestingly, it's still slightly slower than before. We had a really big mini batch size though. So here's the new one. Well, I don't know what happened here. Oh, this is the wrong one here. Yeah, there we go. Oh, okay, yeah. What? That's something. So, well, not quite. There are a lot of things that it has to learn. The original for this is a 107 billion step run. But I don't think I can emphasize how crazy this is, okay? I took a random set of hyperparameters that I tuned for breakout. Very simple game, right? I took breakout parameters. And I've thrown them on a bunch of different environments, and they do reasonably well in all of them. And in half of them, they do better than the carefully optimized set of parameters that I tuned for this specific environment via hand tuning and automated sweeps. So yeah, that's kind of something. That's not something that happens in RL. I am curious as to what they're doing though, because you'd expect one of the other metrics to have gone up by now. They're just very sparse. I mean, that's something right there though, right? Oof. So this is the crazy part, Captain. I deleted the hand-tuned hyperparameters from when I was running. I did this at work originally, and I just like used the defaults that I got from Breakout with the new algorithms and the new tuning and everything. What's different? Muon is a big one. Cosine annealing is a big one. I think those are the two main ones. I fixed a bug, but that bug wasn't in these, like when I ran these original experiments, that bug wasn't there. So I think it's mainly muon and cosine annealing. I'm trying to think if I did anything else major. I think those were the two biggest ones. I mean, also though, the thing is like, because of these new techniques, like the hyperparameters are way more robust, and like you can use bigger batch sizes and stuff without breaking things, which is crazy. Okay, I would like to see this number go up. Muon seems to be just better than Atom. Yeah, it is. Well, it's a small modification on top of Atom, from what I understand, that orthogonalizes model updates. Oh, by the way, you can do this. Let's take Neptune off. It's actually slower in B float 16. And then if you do float 16, it's like maybe a little faster. Not great overall though with the precision. Okay. These are crazy results. These are really crazy results. I don't think that's going to do anything, but I'm just going to run this while I'm thinking about other stuff. Because I'm like, where do we go from here, right? We kind of did the thing. Built in. Okay, so I have to fix that one. That's fine. I think we want to get a really nice policy on neural MMO3. We want to get a lot of the tuning stuff working. Gee, it's kind of the same as before, except now there's more of an emphasis on baselining more M's. Man. Okay, so here's default connect 4. Actually, I want to take this graph. This is Pong. Oh, okay, so this is our original Connect 4 right here. It works, right? This is 4096. Total M's. So we'll just do this is 4. And we just delete this, and what happens? Well, it's a bit faster. Yeah, that might have been a little ambitious. For a 10 million step end to train that fast. It started taking off. Hang on, let me just see what they did. So, batch size 32K. Yeah, there we go. Just needed the batch size reduced because there's like so few total steps. Okay. Yeah, Spencer, there's Connect 4 in 20 seconds, matching previous baseline. With untuned hypers. That's pretty damn good. If we run it for 20, does it do any better? Holy. That gets you 95 in 40 seconds. A little better. That's kind of crazy. We should definitely use this as a baseline. The only thing that's slightly annoying is this env is way too slow. Like the scripted AI is way too slow in this. What other envs? Multi-agent snake. I haven't played with this one in a while. I want to do the full size snake. Let's write this one. Live evals on new models. Oh yeah, we're gonna want to do that. I have to fix some of the eval stuff for sure. I think I broke a few things. I want to like at least get these configs cleaned up a little bit first, and then we'll look at them. And this is gonna be just amazing for research. Where did I screw up? Oh. Okay, this Muon auto tuning is really annoying. It also lags everything because it spins everything at max. Okay, so this is Why is this running at 3.8 million steps per second? That's a bit much, isn't it? It's also the snakes aren't very good, are they? Length is 60. Oh, I think I went off of episode length with snake, didn't I? Hang on. Yeah, I went off of episode length. Okay, so 88 is already better than we had before. This is not RL being cursed. This is multi-agent dynamics, specifically. So you get a pass on this one. Yeah, you get a pass on this one here. Wait, value, hang on, what? What? Wrong one. Score. Is this the, yeah, this is the wrong one. Oh. Okay, that was a random sweep. This is actually perfectly stable. So we have perfectly stable 3.8 million step per second training on snake. We got to figure out what it is that makes the snake M so fast compared to the other ones. Oh, and it evals at 109. That's crazy. And what if I do this? This probably actually does make it slower, to be fair. Hey, do you have a Neptune fork or just install? You just pip install it. I just haven't pinned all the new dependencies to dev branch yet. You probably are going to need to install, well, make sure you do pip install -e dot of cleanRL. Make sure you add the cleanRL args. That'll get Pyro, which you need for hyperparam sweeps. Is it just an insane number of agents in a fast M? Pretty much. But honestly, here I just set these to way more reasonable params and still at 3.4. I had to go back to an old commit because of CUDA stuff. Yikes, yeah. CUDA might be AI complete. So this just matches perfectly, or did I forget to save this file? I think this just matches perfectly, right? I'm gonna run it again. Where do I need to put my Neptune API and variable? Yeah, if you just click the link that's like, you know, get my key or whatever, it'll link you to get your key. And it'll just say, yeah, paste this as an N variable. I mean, as you can see, I've been using Neptune pretty much exclusively for the last couple of months, and I really like it. Like, the dashboards are better, the UI is faster, it displays more data points, it's better for organizing my work, it's just better overall. We're going to support both. Like, I don't see any reason to drop WANB support, especially with the number of people using it. The only thing we're dropping support for is WANB Sweeps API. So you will still be able to do sweeps using WANB, but you're not going to use their sweeps API. You use our sweep tools. Never done real sweeps? Now getting, yeah, sweeps are like goated. You need sweeps. Like, people not sweeping hyperparams is one of the main reasons RL didn't work. Sweeps are like not optional. It's the first thing people drop, and it's like, it's so essential. But to be fair, I've been using the same set of hyperparameters for all of these environments now with the new optimizer stuff, and it kind of just works. So the new puffer update, the next puffer update that has all this stuff, is going to reduce the reliance on sweeps by a good margin. They'll still be good, but it won't be as bad if you don't do them because our defaults will be way better. Okay, I need to change one of these hyperparams to see, like, if I just do this, does it change the curve? It should. How the breakout params applies. I think it's just that the optimizer is way more stable and less fiddly than before, frankly. Like, the main thing is that now you can actually train at large batch sizes, and the optimizer doesn't just like give up. Learning rate scheduler is good as well. I mean, it's just better overall. I don't know what to say. Okay, so here I definitely am using the right params. Not this one. I mean, this is just remarkably consistent, though, this graph. Like, snake length with steps trained. Oh, if you look at score, it's a different story, though, right? So this was the original, and this is my new one, so my new one is better. Oh, no, it isn't. That's the relative time. Okay, this is the same. This one you can see is going to be stretched out because it takes, because it's running slower. But I think in terms of episode length, yeah, it's remarkably consistent of an environment. I mean, it makes sense. It's like it's a very self-similar environment. Okay. I'll let this finish, and then I'm going to do a slightly more ambitious. I want to see what happens over 500 mil with this. Crazy progress. Man, you know that this was my goal for the end of the year, pretty much? Was like, get RL to be stable and consistent. And like, even last week, this was still kind of a crazy thing to say. And now this week, it kind of just works. This is nuts. Perfectly stable learning curves. Many applications? Well, this is the goal, right? If you make RL sane and consistent, you can throw it on a ton of problems in industry. And hopefully, at least some of them will want to hire Puffer for them. At least initially, I don't know why you wouldn't. We don't charge that much. Eventually we will be looking for much higher value contracts, but for now it's like, it's really cheap and easy to get us to look at your problem. It's kind of a no-brainer. Okay. So now here's my question. When is it going to level out? It can't go up infinitely, right? Like at some point the whole screen is full of snakes. But does this just zero shot beat the previous best thing I've ever seen? What? Uh... Okay, I'm gonna have to render this to make sure that I'm not, like, going insane here. There's no way that this could be a reporting bug, though. There's no way. How? What? Once I have some time, I need to try training Impulse Force. Yeah. Um... Okay, we need to render this because what? It just keeps going up? Like, what? What about score? Well, they're living for 182 frickin' time steps. Okay, look, at least score levels off. There's only so much food. What's the previous best length you've seen? Like 110, maybe 120. And it's still going up in like a straight line. And this is one of the M's I actually spent a good bit of time on. Holy hell. Gosh. It's gonna take me a second to get render working, I assume. Maybe they're less janky? Could be. I mean, I've been saying for the last 2 months since I got back more, 3 months, right? Exactly how we fix that, right? With the continuous versions of these arcade ads. I see bet is up. Lodge its values. Spencer added, yep. Yeah, we can just run those experiments. We'll fix that. I don't know why it's so slow. There's sleep on this. Thank you very much. Wait, but it's 10 that would be fine. It's way slower than that, right? Yeah, that would be fine. 100 ms is 10 steps per second, which is what you would want for Snake. That is way too big. Why is the action this big? Wait, n fargs, num m's. Oh, that's an issue. I'm surprised that works. That's a crazy number of m's. Or something. See what the model does. I broke the term. Okay, here's Puffer Snake. They don't seem very smart. Don't you need one env if you're gonna watch it, not 16? Yeah, it doesn't matter. Like this is running 16 and it's still like running in real time for watching it. So I don't see like this policy doesn't look good, right? Maybe it was score. Maybe score was the important one. Hang on. Yeah, maybe I just screwed up. Okay, maybe this particular env I screwed up. Reward food, reward corpse, reward death. But I thought there was like a snake length param. Was score consistent? Score is also consistent here. Couldn't be learning, could it? Well, that's why it was so fast, actually. Because I was actually saturating the GPU. Massive amounts of data. Yeah, 1.5 mil. Oh, it is score is the variable that matters. Okay, I'm dumb. I mean, it immediately jumps up. And what did I just specify? So 256 times 16 is 4096. So this is correct. Yeah, okay. So that particular graph I had was stupid. Get rid of that one. The rest of them are all correct, though. Yeah, there you go. So the real one that we should be running here, get this. Let's let it run. Let's see if it figures out anything smart. This is the end where diversity is all you need actually helped. Helped a lot. It's actually going back up. But you got 3 mil before by running more M's per process. Right, yeah, it was just like a massive number of M's. So the GPU was... The reason that that worked is because Snake has pretty small, compact observations. And we were sending it like... What the heck even is that? 160K batch size or something ridiculous? Maybe it was like 40K. It had a big batch size. So, yeah, that's what happened. We should probably play with that at some point, because it was interesting how well that worked. Uh, this is actually kind of cool that it is now going back up with default params. There's some multi-agent like competitive dynamics going on that make this end a little tricky. It's like very easy to get snakes that do something reasonable, but then there are like some pitfalls that you have to avoid to make the policy really good. I mean, this is solid. Technically competitive self-play? Yes, it is. It's in fact strictly competitive self-play. Good policy. cool environment in the sense that you can train it. You can train something reasonable in 10 seconds, but like it gets meaningfully better if you train it for 5 minutes, like 500 mil steps. So this is what a good snake model looks like. It's kind of cool to watch. I haven't seen a single one die yet. Oh, there's one. A couple died so far. That's a good policy, though. It's not like biasing towards one side excessively. It's a really cool policy. Yeah, I like this environment. These like big multi-agent M's. These are fun. Cool sim. Very, very cool sim. Yeah, this policy is definitely better as well than what we've had before. Like it figured out. So what happened here is like I can guarantee you, it figured out how to kind of like do some stuff, and then the snakes get a directional bias, so like they all go in one direction, and that works fine until they crowd up against one side, and then this is them figuring out not to do that. No, it does not outperform the scores on diversity is all you need yet. But we'll see what happens when I try it with, the new optimizer with all that. There's more research to be done. I'm very happy with this result, I will say. This is very good for this M here. Very cool M. Cool. I mean, we're through half of the PufferLib catalog already. And like you can see, this is one set of hypers. So the whole puffer catalog so far with one set of hypers, modulo a couple small batch tweaks for the ones that have really short horizons. See, we did this, we did this, we did this. Let's do triple triad real quick. Go might be interesting. Yeah, I think that's going to be fiddly regardless just because of the way it's set up, but we'll see. Get our baseline in. There's a Pong run. It's got to redo all the optimizer. I'm going to actually kill this after it's done so that we don't screw up our graph axis. Well, that's nice. Be right back. I'm gonna use the restroom. Yep. Well, that's a super clean train curve with just the default, like optimized ones. I actually don't know what the max is on triple triad. I think you can technically get 9 points, but I don't know if that's ever possible. Maybe Spencer knows. Also, what was the train speed? 1.3? That's pretty good. Okay, so it's like a little tiny bit worse, it looks like. Mini batch. Yeah, I'm gonna guess that this one you can probably do way better just with like smaller batch or something with the episode length being that short. We'll try that next. Oh, and also let's do this. Yeah, so this more M's, fewer M's doesn't really matter here. It looks like it's probably just going to be the batch size. Probably do this. Okay, that does way worse, interestingly enough. You see what the original was? It was 4096 M's total. Bigger mini batch. Let's try this. Well, there you go. Okay. Is it going to get stuck at the lower max though here? Oh, no, it doesn't get stuck. We'll see if it does seem like it flattens though. Yeah, okay, it does flatten more than the other one. Okay, so this one is somewhere in between. You only need an episode length of like 16, I think, right? So it's like, uh, that's 131K. We'll see. But I think with the way that we handle trajectory segments, you might need a little bit of wiggle room. Let's see. This looks worse. Increased batch size is worse. We had 131 before. If I just do 131, and I do 28 ems. It's probably pretty good, right? Of course, it'll take a hit to the train speed. I mean, we don't need to get these fully optimized. I just want to have something like pretty good. Not this one. This one. So the original tuned ones are still like a little bit better, I think, in their final convergence. Unless this catches up. Did you try the other optimizers? So the other optimizers have a big performance penalty associated with them. Muon is the one that runs like as fast as Atom, and just is is a free win. Because right now we have this axis in steps, but usually we have it in seconds, right? I don't really care much for this ample efficiency, nerds. Okay, that's cool. So this is fine. Triple triad works. We need to do the grid M's, our wear and trash pickup real quick. Those should be easy. Look at that. This is fast, but does it do anything? Oh, it's the length is the thing that matters here, right? So lower length is better. Okay, so this is what we get with the defaults. Whoops. Okay. So just out of the box, we just blow the previous result out of the water. So we can just reduce the number of steps needed for this environment to 50 mil, right? Like, there's no reason to have it. So we just increase sample efficiency by a factor of 5, 4, whatever. Okay, that just works. Why wouldn't it? Uh, it's just a custom conf. There's like not even anything remotely complex here. We probably have like a ton of M's in this one as well. Okay. Here's trash pickup. This one I believe is score and episode length or whatever. So I don't know, we'll just pick a metric. Is this the right one? Yeah, that's Pong. Okay, this is good. So previous opt-in params, 100 millisteps, 1.7 millisteps per second. And then what's this? Divide by num agents. Num agents is 4. So I think we literally just delete. I'm gonna leave the batch size. Maybe not. Maybe we just do this. No, maybe we just literally do. Hang on. Just do this. You know. Oh. Yeah. Oh, is it gonna get stuck though? Oh no. I think it's gonna get stuck a little bit. It's so close. Is it like permanently stuck? Wait, it has trash collected at max. But I guess it's the episode length is too long? That's weird. Wait, what about episode return? Oh. So it broke the env. I guess it's just like this little decline. Well, I think it broke the env. I don't know. Here, let's do batch size. Set the batch size, see if that does anything. Yeah, whatever this score is doesn't seem particularly well correlated with the return. So we gotta fix that. Because, like, look, right? It's like 20 is solved, and then it's supposed to, I guess, get penalized for taking too long. But, like, the score is not very well correlated with the return. So it's the episode length, I guess. That's weird. Six. Yeah, this is the one you want. So yeah, that's a weird problem to have. Let's see if we can fix that. Definitely something screwy. Oh, it's probably just a discount factor. Would that make sense? Maybe it is the discount factor here, right? Just try one more thing. So one other, like, do you see anything else weird here? I see like the lower gamma. One mini batch. 001 learning rate. Yep, that was it. So it's this frickin' the episode length here, right? It's gamma. Yeah, so that's a gigasolve. That's gigasolved. What else do we have left? We did everything but go, right? Let's get go running. Also, we really would like to have like a much longer benchmark on Neural MMO3. That's the cool end. I mean, not that's the hardest end, I will say. Neural MMO3 is definitely the hardest end. Okay, here's the restroom again. I'll be right back. All right. That does not appear to be doing anything good. Also, why is this training at 50,000 steps per second? Hello? What is wrong with Go? Why is it like this? Why is the mini batch size 131K? Who did this? That is not how GPUs work. Don't do that ever. Thank you very much. Is it still slow? No, 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 no. If it's still slow, then we've got issues. This has got to be like the stupid action space, right? Model's really slow? What is the model? conv2d 2 channels 3 stride 1. Is it the logic somehow? Hang on. Let's do this. 500,000 steps. That's what's wrong with this, right? There we go. Yeah, so it's all in the network. And we have not high GPU utilization. Oh, hang on. Let me see if the batch size is what we think it is. This is what we think it is. This is all zeros. I guess that's fine for the start. 48. Default policy is much faster, but still way slower than expected. Is it the action space being weird? That doesn't seem to be it, right? Still slow. fact that they're 17% forward. Like, how is there 17% in just this of that? Default network. I just want to make doubly sure that this is actually getting applied. Yeah, so this is getting applied, right? Policy is just super basic, same as we use everywhere else. Not continuous. And somehow this is slow? Really? Device equals CPU. Yeah, okay. Okay, buddy. $1.4 mil. And now let's rerun again with the bigger action space. $1.0 mil. Okay. So there is actually some sort of perf penalty, it seems, associated with that. We should look into that more, the action size. But for the meantime, this is good. And we can actually run this. This is too many steps to give it. We'll give it 250. That's not going to matter for this because there's no annealing on. So at what point does the learning start? The episode return's increasing, so I think this is the part where it takes forever to learn action masking. You can see the episode return is actually optimizing though. And now score starts to increase very rapidly. And now it's winning almost all the games in only 100 mil steps. So 100 million steps should be fine for this. Cool. Now we do the exact same thing as before, but we delete all of this. And we see how the defaults work. Oh, 0.991 win rate, actually. So 99% of games won. And then we will see whether our new params are any better at getting unstuck. Oh yeah, look at that. The episode return. That is optimizing much faster. The steps per second have taken a big hit for some reason. Let me see. Oh, you see anything that would cause that here? Size, mini batch size. I don't see anything that should cause that, which is a little weird. Oh, actually, hold on. Maybe I didn't see these steps. Yeah. No, it gets slower as you get better at the game. There we go. There's the jump. So, be better than previous. Yeah, better than previous. That's crazy. So we've pretty much just shredded every single benchmark in Puffer. I guess we can try Blastar real quick since Bet went through the effort of making it. We may as well include it, right? It's a fine end. It's a little silly of an arcade end. What did he set the total time steps to? A lot. Okay, Bet. Invalid environment name Puffer Blastar. I literally not even included in yeah. Welcome, YouTube folks. Today is a very good day for RL. If we can just finish this last M, then pretty much we have one set of hyperparams that works for all but one of the M's. And in the cases where it's like slightly suboptimal, we know that the last impediment is generalized advantage estimation, because you just cannot use the same gamma and lambda params for all M's. I think once we have that set, we should be good to go. Maybe entropy. Entropy might be a little M specific. We should be able to make that adaptive though, pretty easily. Much more easily than the other ones. So massive episode length here. I wish I knew, so this is go. I wish I knew what score we could get. What's the max score? But I guess what I'll do, since he has the set for way too long, I'll just let this run for a little bit. Actually, this might be good right here, 100 mil. Yeah, because it starts oscillating. Cool. And that's just from the long episodes, I assume. Num-m's 4096, and batch size is 1 num-m. So we're going to change this to 2048. And we'll just do this. Actually, hold on. You want to get rid of everything except total time steps. There. And the score is already way higher than it was. Yeah, look at that. Yeah, massively better. Now, these should start at the same point, mind you, but still, like, massively better. Just make sure it doesn't get caught at 21. Is it stuck? Oh, it's still going back up. What was his original gamma and lambda in this? Nothing crazy. Okay, I mean, so it gets to there immediately, which 25 is max score. Yeah, I wouldn't be surprised this is just like a weird episode length smoothing thing, because 25, if you look here, right, like with the oscillations, it averages at 25. So the max. Okay. Generally, though, we have reasonable on every single end. And if this is matches, I have to ask Bet if 25 is solved, because if so, then this is solved right here. So, and then this is probably, well, this could be like slower oscillation. We'd have to run it way longer to see. Main thing, though, for now I did have a sweep running. We do have Pong. And it looks like the current best for Pong is about 22, 23 seconds. Does anybody remember what the previous best time was for Pong? Did I tweet about this at all? Can I like search my own tweets? Maybe search Discord? $50 was the original over here. I thought we had faster than 50. Does anybody remember? I guess I could go back to like one of the old sweeps. Oh, your Pong M is solved in 25 seconds. There. So then if we had 25 before, then this is about the same, but this is like the easiest end. So maybe that's fine. We also, hang on. Let me try like one or two quick things with Pong. I bet I can get it to run just about the same. $25. So this is 20 million steps-ish. 22 seconds. Okay, so this is 22 seconds. Uh, 15, so 16 mil. Does this like have a weird number of M's though? 12 M's. Okay. Just see if there are any weird params in here. One update epoch. 8192 mini batch still. 131K. Yeah, let me just reduce the size. You don't get any data from this. Negative 13. Too many M's, maybe. This is probably pretty close to what we have in the sweep. Oh, and then it just jumps to 20. Okay, cool. Shouldn't be anything else major in there. Solved in 30 seconds. Versus the optimum we get is like 22. And all I did was match num-m's, I guess. And batch size. Seems fair. Cool. So even though this is like 10 seconds more or 9 seconds more than the optimized one, I'm still going to say, right, like 30-second solve, absolutely same set of hyperparams works. You might have to tune batch and M size a little bit for the simpler ones, but that's it. So we now literally have, except for like one gamma tweak that we needed, we have the same set of hyperparams working on every single environment in PufferLib, which is something that would, I would have said is like batshit insane if you'd asked me literally yesterday. And I mean, anybody who tells you that that's not insane is just lying or wrong as well, because the papers that have claimed to do that have been borderline fraud. There's one or two in mind I have for that. So this is an insane result, a truly, truly insane result. I'm trying to think what I want to do next with this. Let's open up Neural MMO3. It's a mincom prof, I believe. How long does 10 billion take? If I run Neural MMO3 for 10 bill, maybe we see something interesting. 0.5 bill an hour. I'd rather do this though and have the original. I don't know if that'll screw up the annealing, but I think I'd like to just do this. Or was it environment? Neural MMO run setup. I mean, this will be the real test, and this one might actually take a bit of work. Neural MMO is a hard env. There's a reason I haven't been using it, even though I love this environment and put a ton of work into it. It is hard. I'm gonna make sure that this actually gets going. Here's gonna be the plan for today, though. So we have all these new baselines. This is kind of nutty that this works. I'm still kind of in shock here. We're gonna run Neural MMO here. I might want to hyperparam sweep this, actually. On the other box. I might want to run a hyperparam sweep on the other box for this as well. So yeah, I'll do a few more things right now then. Okay, so this runs 500K. Numems is 4. Okay. So up to 8192. Is it 1 or 4 by default? It should be 4 by default, I believe. Total time steps. 1E9 should be the max. 2E8 min, enough. 5E8. And I don't think I can use min.com.prof as the metric for sweeps. Let me go look what I can use for neural MMO3. I think it's episode return. I'm gonna try this. Hopefully this does something. We'll see. I'd love to get a nice policy on neural MMO3. That would be like the full circle success. So that's such a hard end. Like, if you want to get a sense of what neural MMO3 is, you can just play it on Puffer AI. Like, that's the best way to do it. It requires a lot of things that are intuitive to you because you can see the textures and say, oh, that's a weapon, I should go get that or whatever. Or like, oh, I should put this tool on. Like, I should equip this tool and then gather stuff. But even then, it's still like, the mechanics of it are hard. It requires like longer term planning. It's just hard end. You'd have to compile a bunch of stuff, right? Yeah, it compiles a bunch of stuff. Looks like we have quite a few folks watching, which of course this always happens right when I'm about to pass out from having not eaten anything. So I'm going for lunch soon, so we get these things done. The plan for the rest of today, so quick summary. We have all of the M's in Puffer working very well with basically a single set of ultra-fast hyperparameters. This is with all the new tweaks and algorithmic changes we've made. We have a clear path for what needs to be done in order to really make a single set of hyperparameters work for everything. That's the P30 or GGAE stuff, the new algorithm I've been developing. We have the potential for the first time now to get some really impressive results on M's like neural MMO3, maybe even impulse wars and some of the other complex ones that contributors have added. And I have a couple more M's to add bindings for. So I'm going to finish this. I'm going to grab lunch. I'm going to get a little bit of exercise, do a couple things, and then I'm going to come back, add a binding for a new environment, see how all this stuff works on that. Probably clean up another environment. There's like some client adjacent stuff I have to do. And then we will look at the results that hopefully we get some cool results by then as well. And we will proceed from there. And I also want to try out the P30 stuff now with all these new algorithm tweaks, because it is quite likely that we're going to get some qualitatively new results. And if I can get like consistent baselines on neural MMO3, that would probably be the best possible setting to try out P30, because it's an environment that really requires you to be able to do credit assignment over differing horizons, depending on what state you are in the nth. So that's promising. This literally just takes like a while to start increasing here. Okay, so this sweep is running. This baseline longer run is going. For the folks watching, all this stuff is open source. You can get it at puffer.ai. Start the repo to help us out. Really, really helps. It's free. It takes like 3 seconds. And if you want to get involved with dev and all the exciting RL advancements happening right now, just join the Discord. You can click the button, or it's discord.gg/puffer. If you want more RL content or want to get notified when I'm live, etc., I stream like 40, 60 hours a week of dev on X, YouTube, and Twitch. So you can click the button here for X and more RL content. Thanks, and